right. Hi, my name is David Dalton. I work at Microsoft as a Web Apps and Frameworks PM for developer experience. What that means is I just do open source all day. One of the things I've been working on, I'm also the creator of Lodash. How many people have used Lodash here? All right, sweet. I should have probably led with that one. But over the last year, I've been working on the ESM problem. And the ESM problem is, so browsers have, all modern browsers now, Edge, Firefox, Safari, Chrome, all have support for ECMAScript modules, which means you can go script type equals module, then you can support import, export. Some even support import.meta, dynamic import, all this cool next level like language stuff for modules. But Node is a different story. So today I'm going to talk about how you can get ECMAScript modules in Node 6+ today. So, cool. So to do that, meet ESM, a fast production-ready, zero-dependency ECMAScript module loader for Node 6+. Basically, you do this. So, if you all have computers, you may have computers, you can follow along. All you have to do is do npm init ESM. You can throw in a Y flag there, which just answers yes to all the prompts. And now you have a package that supports ECMAScript module syntax in Node. With just that. What that's doing behind the scenes is creating your npm your package.json, adding ESM as a dependency. So this is actually an npm package called ESM that will automatically be installed, and the index.js and main.js are created for you. So super easy to get started. If you're a fan of Yarn, you can do Yarn create, same thing. So one of the things I did when I was creating this was make sure that you could jump in as quickly as possible and start to explore. So there's no better way to do that than the REPL. And so you can do that with node r ESM. So the R flag, or the longer require option, will allow you to load a module up before Node executes. And so in this case, when you do this, your REPL will then be able to support import-export. You can do dynamic import. You can do import.meta. All of that stuff just works. So one of the other cool things is the require option to tools. And I kind of hinted at it with Node require. But this also works for Mocha, NYC, so your code coverage, your unit testing libraries. In this case, even Webpack supports it. So Webpack, how many people have used Webpack here? Great. Cool. Well, Webpack has config files. And those config files are usually written in CommonJS. But now with the Webpack R ESM, you can write those config files in ECMAScript module syntax. So you can have import-export. That way, all of your code can be written in ESM without having to go to CommonJS. This works for just about any tool with a require option, too. So even if I don't name it here or in the README, chances are, if it works with like Babel Register or anything that Babel has already gotten support for, then the ESM loader will work in its place. You can just drop Babel, run this thing, and be off with ESM syntax without having a heavy dependency there. If you are into Ava, so Ava is a unit testing library. One of the things that Ava does is that you really don't have to configure a ton of it, right? You get support for ES6 syntax out of the box. But what it was usually using is Babel. So you have to download a ton of Babel, deal with the transpilation every time you want to run your unit tests. Well, with their beta release, they can now you can now opt into just using the ESM loader to do that. And so there's a link here, and I know y'all can't click on the link, so I will just show you here. OK. So with their configure, you just say, again, require, and then ESM. I'm going to try to do a zoom here. All right. I tried it earlier and got into trouble with it. But there you can see here, it's just Ava require ESM. And if you want to, you can disable Babel with a little bit extra config there. And now you don't have to deal with all this extra transpilation. It just works out of the box with ESM syntax and for your unit tests. So cool, let me zip back here. It's 0 configuration by default. Everything you're used to doing with Babel for ESM syntax will just work with the ESM loader. So node r ESM, if you init a package with ESM, your common.js, so if you want to import Lodash, for example, and you do import the pick method from Lodash, that just works out of the box. You don't have to opt into anything, configure anything, so you can get coding fast. Right. It aligns with ESM today. So Node has experimental ESM support. Node 8 Plus has it. You can pass a flag called experimental modules, and then you get import-export for files that end with .mjs. How many people are familiar with .mjs? OK, just a few. Great. So this .mjs stands for modular JavaScript, or modern JavaScript, or Michael Jackson script. I don't know. But it's a signal for Node to be able to say, like, this is not common.js, this is ECMAScript module syntax, and to treat it like that. But there's some friction there in the ecosystem with that, because it's a new file extension. People are very attached to .js. And the way you do things today with Babel, you never had to think about like the file extension. You could do things with standard in. I'll show you an example later on where I'm starting a source file from scratch without an extension, and ESM still works. And so this allows you to do support ESM with all of that stuff today without having to worry about what the experimental path is. One of the other things there is it does synchronous loading. So common.js, when you do a require call and you require a module, it's happening at the time the require function is executed. It's not creating a promise that then resolves later. And one of the things with ESM syntax is that it executes in 3 phases. There's instantiation, there's creation, instantiation, and evaluation. And each one of those phases can happen asynchronously. They're not mandated to happen asynchronously, but they can. And so Node and the browsers do execute them asynchronously. The problem is that asynchronous behavior and common.js's synchronous behavior, they don't line up, right? You're going to have some friction there. And so the ESM loader will work synchronously. So if you're used to doing it with Babel and you have import Lodash, which then is behind the scenes a require call, and then you do a require call after that, they all execute synchronously. You get things like dir name, file name, require, and other common.js things. These are things you take for granted, right? You use them all the time. But in the Node, like future ECMAScript module support may not have these things. And you may have to use something else to get them, right? Like use a helper function or pluck it off of another property. But that's roadblocks to adoption. And you're already using it today. So again, we support this without having to configure it. Named exports. So named exports are like before where I said import pluck from Lodash. That's a named import of a named export. And that's something that Node currently doesn't support in their experimental branch either for common.js packages in the wild. They support it for their built-ins because I added support for them. But there's a little bit of friction there. I keep saying friction. There's a little bit of tension there because in order to add support for named exports, you technically have to break the ECMAScript spec to do that. Because common.js is one module format, and ECMAScript modules are a different module format, and they don't mesh, right? And so something has to give. And with ESM, we make that concession, opt in to it because we figure you want your stuff to just work, right? So that little execution order nit, we allow for that. Live bindings work. So live bindings are things that you may not have used with Babel, but Babel also supports them. And that is with common.js, you have exports on an object. And so if the object is mutated, the properties on that object are updated. With ESM syntax, you have bindings. So you're exporting variables. And if your parent module updates those variables, it updates the bindings that the consumer can see. And that's called live bindings. And we support that out of the box, too. One of the things we do is lock down the MJS file extension. So I said Node has this experimental module support. And you have to use the MJS file extension. What we don't want to do is encourage the use of something that's experimental, which may change, and then add all this stuff that makes all of your things just work. Because then you'll start using MJS, and you're like, wow, this thing's great. It really works. But in reality, it's all locked down, and it has none of these features. And so if you do use MJS, we give you the support that is currently available in Node today, which isn't much. I mean, your code will run, but all the stuff you're used to being able to do, your code coverage, your unit testing, your mocks, none of that stuff works. And you can't opt into it either. So we force, like, if you use MJS, you get what you get, which is bare bones functionality. And that's on purpose. OK. Oh, there it is, right there, bare bones functionality. So I said before it's zero configuration. But you can configure it because devs have opinions, lots of them. So there's lots of options. You can configure it with a package.json. So you can have like an ESM property in your package.json and throw in a bunch of options there. You can configure it with ESMRC files. And so this is like Babel. You can do .json, .js, or .mjs, hey. And by the way, ESM support is supported in the JS or .mjs formats. So your config can be written in ESM that then is used by the ESM loader. You can also do an environment variable. So specifying ESM options, you can put in there a JSON 6 object. So JSON 6, so it's not a real thing. JSON 5 is not a real thing either. So there's JSON, and then there's JSON 5. And what JSON, I don't know what happened with 3 or 4, but JSON 5 is a thing. It basically allows JSON, but without like, you don't have to double quote your keys. I don't know, you can put comments in between your JSON objects, stuff like that. It makes it usable, right? So JSON 6 is JSON 5, so all of that stuff, but plus support for octals or something. I don't know. It's more language stuff, but it allows you to. That's one of the data formats you can support there. Cool. I noticed something I haven't done, which was show you the actual repo. So I'll go ahead and do that. Let's just see if I'm signed in. I'm not signed in. That's OK. OK, so I've got the org standard things. It was a play on Stranger Things. Hey, I mean, I wanted this thing to feel built in. So if you go to standard things/ESM, this is the repo. There you'll see a ton, well, not a ton, a handful of options. I wanted this thing to be super easy to get going with. So here's the options here. You have mode, common JS, and then top-level await here. And so all of those common JS features, the ones that I have enabled by default, are here. And you can go through every single one of them and toggle them if you like. And so this is the thing that makes all of your stuff just work here. We have caching extensions. Babel does this thing with like a double underbar ES module, which says that this common JS thing actually should be treated like an ES module, and I support that too. There's a thing called mutable namespace, which I never knew people were doing this until I figured I found out that sign-in. So sign-in is a mocking library, so you can stub and mock and spy on your objects to see if they've been mutated and to see what values they have. So it's really good for unit tests. But they would tie it into a namespace object. So namespace objects in ES module syntax are immutable. And so you can't spy and wrap properties on something that's immutable, it throws this error. And so we allow you to have a mutable namespace, so you can continue to use your mocking and stubbing and spy libraries for unit tests. So there's a bunch of those options. Aha, great. Whoop, cool. And then you can use a programmatic API too. And so why there's all these configurations is because there's different scenarios for each one. Say you just want to get up and running and you don't want to do anything. Great, no configuration. You don't need to do anything. If you want some options but you don't have a ton of config files, then maybe you don't want to create a separate config file for that. Maybe you just want to put it inside the package.json. If you're running something like Quokka, or which I'll get into in a later example, there they use the ESM options environment variable because they're running Node in the background and they just want this thing to be configured without the user having to provide a configuration. And then the programmatic API, because let's say you're creating a loader instance and you want one loader to have these options, another instance of the loader to have another set of options. So it allows you to do that. Cool. So mostly JavaScript is mighty good. What does this mean? Let's see. OK, so the loader itself, the thing that you're using, is about 200 kilobytes. It's a zero dependency package. If I was to gzip it up, it'd be 64 kilobytes. So 64 kilobytes is roughly all you need to get ES module syntax support in Node. So if you want to have a package that depends on this, it's a very tiny thing. I'm able to do this, though, because it's mostly JavaScript. It's written in JavaScript. And so there's some knee-jerk reaction to that where they go, ugh, it's JavaScript, but I thought native was better than JavaScript. So one of the things I did with Lodash was show that you can implement vanilla JavaScript methods and have them be faster than built-in methods. Well, so it turns out you can do something very similar with the language, too. I'll get into this one, though. Besides performance, there is zero tie-in or buy-in to dependencies. So Node is not a vacuum. If you want to change something in Node, a lot of times you need to have sign-off from Google, because they own V8, and V8 is what powers Node. And so if they need a new language feature, they're going to have to ask V8, hey, can we have this? And then V8 will go, no. It's not in our priorities. And so then they'll go, OK, hey, standards body for the JavaScript language, can we have this? And standards body will go, no. And so then they're back to the drawing board. But for me, I don't have to answer to V8 or the standards body. I can do what I want. So there's zero buy-in or tie-in from them. So that means I can add these features, I can make stuff just work, and I don't have to get approval from any other group. Faster development. So Node's experimental module support was started in like June of last year and then landed in August. And it was, I don't know, it was one pull request. And that took a bit of time to land and then refine. And since I am a single dev working on this thing, I've done like 125 releases. I can release 2 times a week or whatever. I can test things out and implement feature support for things like import.meta, named exports of built-ins, all of that stuff in days. And for Node, it takes months, right? So a lot faster to just get this done in JavaScript. Greater ecosystem support. So because this is JavaScript, I can do things like simulate Babel support. I don't have to worry about being confined to what is standard or standardized in JavaScript. So that's, again, the whole point of this loader is that your stuff just works. And that's something that can be achieved by writing it in JavaScript. So native helpers when possible. So I like JavaScript, but there's an asterisk. If I can use the native helpers, I want to use them. And so this still allows me to be able to do that. Something you don't get in the browser is that V8 or any JavaScript engine can expose internals and private APIs that allow you to do things like create namespace objects or dynamically create an ES module. Node has access to these APIs, which means I have access to these APIs, or should be able to. And if I can use them, then I will. At the moment, I'm not using them. because they're not quite where I want them to be yet. But I just recently became a Node core contributor, so I'm part of the problem now. And so I can help influence the shape and the design of Node and its module support. So I'm pushing, of course, for a better developer experience, for things to just work, or for a path for things to just work. Maybe not by the default, but there should be a way to do it. Great. So just works. I've said that a bunch. It's in my Twitter name, just works. What does that mean? It means maximize interoperability. So when we start talking about ECMAScript module syntax, there's this existing ecosystem of CommonJS stuff. And so here's some of that stuff that doesn't work with ESM but should and does work with the loader that I provide. Performance monitors. So if you have an application and you want to tie it into a performance monitor, there's several of them out there that checks function calls, checks for your memory usage and whatever. All of that stuff is deep ties into Node's CommonJS module system, which is not Node's ES module system. But because ECMAScript, or the module loader I've written, ESM, I'm going to have to start referring to it like as little ESM and big ESM. But little ESM, the loader, does work with these monitors out of the box. You don't have to do anything. What I've done is, so CommonJS has an interface for its modules, and I make the ES module have that same interface. So to the performance monitor, it thinks it's interacting with a CommonJS module, but it's not. It's actually an ES module. So then the other things are code coverage. So code coverage is another thing that you may take for granted, which is behind the scenes, it's hooking into the module system. Before it actually executes your code, it's taking your code and instrumenting it and wrapping all the function calls in lines to say like what line is covered by executed code and what line isn't. And with ESM, of course, since it does simulate the CommonJS module code path and APIs, code coverage, so Istanbul or NYC just works. Resolution aliases. So this is another new thing that I was not aware of when I started this project. But apparently, when you have unit tests and you have these really long nested paths for your modules, like dot dot slash dot dot slash dot dot slash, you may not like that. And so they have packages that allow you to alias those and say like at test slash. That's it. And all that stuff works in CommonJS. And again, as you can guess, it's because that is tapping into the module resolution algorithm of Node. That is not the ESM module resolution algorithm. Because we simulate that, all of that stuff just works. So unit testing. As I showed with Ava, with Mocha, all of that stuff just works. The one that doesn't just work yet is Jest. So Jest is the one that I've got my eye on. So Jest simulates everything. Everything is fake in Jest. Nothing is real. Everything you touch is like it's a module object. It's an import. It's this or that. It's none of those things. It's all fake. And because it's all fake, it's tying into deep internals of Node to do this. And those deep internals are the CommonJS internals, which is not ESM. And so I'm working on so I've exposed things like the APIs, and I follow the same paths of execution as CommonJS. But there's one place where I don't yet, and that's where Jest uses, and that is dynamically compiling ESM modules, multiple instances of them, through Node internal APIs. And so I have to hook into that. And then once I do that, it will just work. So I've got a proof of concept of it, and it did just work. So that's cool. This is big because right now Jest requires transpilation to get things to work, and that's just another heavy Babel dependency. And if I could drop that, and then you just use ESM as the replacement, kind of like what Ava did, that would be great. And Jest's popularity is skyrocketing. I saw a dev survey where it's like 23%, which is pretty good considering the #1 used unit testing library was no unit testing library. So, that's a good chunk considering the alternative is nothing, right? So that's on my list. And hopefully I'll get that done in the next month. I promised myself I wouldn't release a 3.1 of the loader until then, so that's why I'm on 3.0 0.50 because I keep going like I'll get to that just thing, but I will. I promise. So that's going to be the next thing, to just work. To just work. All right. Yeah. Thanks. Yeah. Great. Cool. All right. Chrome Inspector just works. So when you launch Node, you can say -- inspect. And it opens the Chrome Dev Inspector. And when it shows the source code, it's not going to show whatever the magic is behind the scenes to make it all work. It's going to show you the code that you've written in ESM. So I dynamically source map on the fly. What's also cool is how I make all this stuff work, which I'll get into in a little bit. Everything's inline. So source maps are literally just me saying, look at that file. It's not complex at all. Cool. So work better. And that is, no one's going to use this if they have to do anything, which is a bummer. Because I'm just like, just use this npm command, npm init ESM, and they're like, no, it's too much. I don't want to do that. And it's just, but I've spent a lot of time. Nope. So the ESM loader has to do something more than just instant and seamless ESM adoption, and so that's where you get these things, which is resilient. So Node has this, I'm not going to want to call it a problem. It's a thing. Node has this thing where all of its internals are in the same realm as your user code, which means if you modify the object.prototype or you change these properties, it affects how the internals of Node work and can really screw things up. The ESM loader is isolated in its own context. Nothing it executes inside of its context can be tampered with by userland, which is great. It also means that so Node, because it has this problem, every one of its internal files has like this header where they copy all the object prototype properties and array methods and stuff like that and repeated over and over and over in its source code, which is kind of gross. With ESM, since it's encapsulated, I don't have to worry about any of that. I don't have any scaffolding. I just write my code. And so that's where you get these things, which is resilient. So Node has this, I'm not going to want to call it a problem. It's a thing. Node has this thing where all of its internals are in the same realm as your user code, which means if you modify the object.prototype or you change these properties, it affects how the internals of Node work and can really screw things up. The ESM loader is isolated in its own context. Nothing it executes inside of its context can be tampered with by userland, which is great. It also means that so Node, because it has this problem, every one of its internal files has like this header where they copy all the object prototype properties and array methods and stuff like that and repeated over and over and over in its source code, which is kind of gross. With ESM, since it's encapsulated, I don't have to worry about any of that. I don't have any scaffolding. I just write my code, and I only worry about the barrier, the borders where I expose things to the user, like on a module property or something. Then I ensure that is an array from your userland realm. So there's that. It just works. There's also no cost. So another thing is whenever you talk about implementing these things, the first thing devs will do is they'll knee-jerk and go, oh, performance. It turns out creating a new context is microseconds, and since I create just one, you never see this, like in a perf measurement. Creating this context that exists for the life of the loader is never seen in your perf measurements. So great, it's fast, it's resilient. Reduce pain points. So what I've done there is, I wonder if I get into that over here. I don't. Great. So I focus on the developer experience. And one of those things is errors. What happens when this thing breaks? Right? Whenever your code has an error, whenever you import something that doesn't exist, or you try to grab an export on a module that doesn't exist, or you have a circular dependency, or you have a circular export, all of these things are things that can happen, and you'll accidentally run into them. And the debug experience for ESM is kind of new. And so, for example, like in Firefox or Safari, you may get an error that just says error on line 1. And you're like, what does that mean? So now what ESM does is it will actually say, for example, the export named foo is unavailable on module, and then give you the file path of the module. So you see that, and if it can, it will also give you the snippet of code with a caret that points to your error. So super cool. It's reducing those pain points. And again, everything that should work should just work. I've done some stuff when you try to inspect things that everything looks native to. So you're not going to be taken out of that context by seeing something like a Webpack bundled source or something like that. It feels native. So improved performance. OK. So I mentioned it has to be better than native, and a lot of times perf is a knee-jerk concern. And so how do I make this stuff just work? I parse it. Parsing in JavaScript, slow, right? It's slow for like the first time. But what about, like, how many times are you going to run your code once and never run it again, right? You're going to run that code over and over and over and over. So what I've done is I've optimized parsing, so it's fast the first time. You can use it in the REPL, and you never notice a compile step going on because it's instant. It's microseconds. But on the subsequent load, I cache that, so it's never doing a transform for the life of the unchanged file. But there's something else I do, which is engines produce code when you execute a function, and it contains data about that function, the types, profile data about the function. So I take that data, and when the process exits, I save that to a buffer. And then when you relaunch and you go to execute that same code again, I feed the engine that data. So it's optimized startup. So you get a performance boost by using the ESM loader on your CommonJS code and your ESM code. So today, everything is CommonJS. The majority of your code is, right? So you're going to get a perf boost on your load for just using this ESM loader. And then as engines optimize, I'll be able to improve the ESM code paths as well. So you're doing that. Oh, by the way, so this thing I'm doing to improve perf on startup, so V8 has improved its API for that, so I can collect even more profile data, which means you'll get eventually a 20 to 30% performance increase there, which is great. And since this also applies to CommonJS too, why wouldn't you use this thing? You're going to get a perf boost on your CommonJS, on your ESM. It's great. So power up. Remove artificial barriers and empower devs. When you look at ESM syntax, you may think, great, this is import, this is export, but none of my stuff would work, right? Which means you're not going to use the ESM syntax. You're going to keep using CommonJS, because that stuff just works and always has. So what I do there is I allow ESM to be used for full stack, which means your front end can be ESM and your back end can be ESM. If you follow me on Twitter, I just tweeted a couple examples of isomorphic JavaScript. They said it was for isomorphic rendering, but one of the pluses was if you used ESM, you could have import for both the server side and client side. You can also do this for things like, I wonder if I touch on it. I don't. If you have Electron apps, hey, Electron has Node built in, and you want your client-side JavaScript to be ESM. Well, now your server-side or your Node side can also be ESM. And it works. Oh, by the way, this thing works in Electron 1, Electron 2. No worries. You include it in there. It just works. Cool. Real time. Because this is very fast in microseconds, you can use this in real time. And I have a demo showing that. So like in the REPL, in Quokka, or Wallaby.js, which are things you can add to VS Code, which allows for live debugging and like magic comments to show your code and values. All of that stuff is powered by ESM now. So you don't have to have Babel, and you can just start typing import-export. And it's in real time, which means it's fast. It's great. Cool. So what's next? There's plenty of things to come. Loader hooks. So that's going to be something that will allow Node to maybe Node doesn't have all of this stuff by default, but you can opt into it with a loader. Loaders can do anything, like this ESM thing. So there'll be that. I'm watching that syntax. It hasn't been fully fleshed out yet, so I'm not going to like spend a lot of time trying to support something that keeps moving. Node tooling benchmarks. So hey, so I maintain Lodash. It's a thing in Node. And Node's benchmarks have been focused on the ones I would look at. There's like web tooling benchmarks, but they're all focused with code that runs in the browser. And Node is usually server-side, right? Not the code that runs in the browser. So I'm working with Node to create a benchmark that would improve the performance of things like Webpack, Babel, Lodash. Hey, maybe this module loader. Yeah, great. So that's gonna be there. This was going to be what's next. I added this feature to npm, which was the npm init package name. You can use that for any package, any create package name. So your create React app, you can say npm init React app now, and it would just work. So cool. Experimental WASM support. So WASM is this thing that allows close to native perf. It's like 10x slower than native, but it's a lot faster than regular JavaScript. I support that too. It took like an evening to implement. So I say I support that. I haven't shipped it, but I added support for it in an evening. It's super, super easy to do. The reason I'm holding off is because I promised Jest support first. So you don't get WASM support until Jest comes. So yeah, I'm trying to motivate myself here to tackle that one. Great. So a deeper dive. So that was normally supposed to be a 20-minute talk there. So I have time to dig into this. But OK, I want to get into how do you actually use this thing. Before I said there's this thing allows you to load ECMAScript modules, but then your CommonJS is seen as CommonJS. There's something called a application level loader and a package level loader. So an application is something you would run with Node, R, ESM, and then the entry point to your application locally. But if you have a package, you want to be able to ship ECMAScript module code without having to ship two versions of your package. You'll see some packages nowadays, they'll ship their ES module code and CommonJS code in the same package, which doubles the size of the package, has two arbitrary code execution points, which isn't great, because let me tell you, the transpile thing is never 100% what the actual thing is. So you have places for bugs to creep in, right? So with ESM, you can actually use this for the packages you want others to consume, and they never have to know its ES module syntax. To them, it's just CommonJS. It works. And to do that, you have to create something called a bridge. And since the ESM loader is bridging the gap between the ESM of today and the ESM of tomorrow, it's also bridging the gap between CommonJS too. And so in this example here, I've got a module in the index file. I'm redefining require as a loader from ESM. So I pass this module here to anchor it into its current directory and all of that stuff. And then the next thing you load, so this main.js, is actually ES module code. The export, all of that jazz, just works. And then you can export it as module.exports. And then any package in Node can then consume this. And to them, it just works as ESM. They don't have to care about the extension, the syntax. It all works normally. So that's the bridge. And that's the 2 lines of code you have to write to get it to work. I know, it's 2 lines of code, right? And so that's why I created npm init ESM, because it writes those 2 lines of code for you. So then you only have to write 1 line of code, and it does the 2 lines for you. So I got that. Babel interop. So this is kind of cool, and I did not realize this until people started to use it. So you have your ECMAScript code, which is import-export. You have the bridge, which is CommonJS. Then you have things consuming it. And one of the things that consume it is Babel. And Babel will look at that CommonJS and go, oh, it's CommonJS. I need to treat it differently. But because interop is enabled by default, we add the __ES module, which tells Babel that the thing that it's consuming, even from the bridge, is ESM code. And so now you can have your real ESM code read by Babel, and it still works as ESM code. It knows seamlessly to operate between the two, which is crazy. So you have real ESM, CommonJS, Babel, and it all just works together, which is cool, because this is something that, like Ava before, if it's using Babel, would have errored, because it's trying to load real ESM as CommonJS. But this all just works. It's super cool. Multiple instances. Because the loader is isolated and doesn't affect everything, it's only your package, you can create multiple instances of the loader. In this case, I'm doing one with top level await, one with CommonJS support disabled, and one saying mode all, which is everything is ESM, regardless of extension. It's all ESM. So you can create multiple instances of the loader. It also shares data between them, kind of geeking out about that one, too. So it's optimized for creating multiple loaders fast. All right, Q&A time. All right. All right. I say Q&As for hallways. Let's see. The pipeline here, this is just because I think a lot of times we talk about surface level stuff, and getting into the pipeline is important. You parse, you validate your specifiers and exports, and I do the same thing. Then instantiate and evaluate, and I do that too. So this is the synchronous pipeline. This is something that modules do too, but they do it asynchronously because they have to deal with HTTP requests, right? So getting that source is, you never know when that's going to be returned. So unambiguous mode. So this is how I can take a file without having to know what it is and then know what it is. And that is, if it's MJS, I assume it's module. If it's not, if it has a static import, export, import meta, or the use module pragma, that's something that's non-standard. But if you use it, I'll treat it as a module. Then that's what I do. I do that quick parse. Else, it's a script call. So then it's CommonJS. The interoperability modes. We have. This is the pipeline for validating this. I resolve the module specifier. If it's a module goal, then I validate all of its exports and bindings up front. If it's CommonJS, then I punt to the evaluation phase. Because CommonJS, you don't know what you have until you've executed it, right? So you have to execute it and then get the value. And the spec purist will go, that's different than ESM, because ESM, you know all of your errors up front. But I would argue that CommonJS has always worked like this. It's always executed the code. You could change global state before it throws that error, but most people don't. And so mine, I just go with the way that CommonJS has always done that. Instantiate and evaluate. Then you link up your export bindings, and I do the same thing through code. I validate the exports then, and then I can do things like populate those bindings, those live bindings. Caching. So before I kind of hinted at it, where you do one thing once, and then after that it's all cached. So I cache loader data. I cache all of the source transforms. I cache all of the metadata associated with the module. So I know that an ES module has these exports up front before having to evaluate that module again. Once I've seen it once, I know all of its metadata, which is something the browser doesn't even do yet. So hey. And then engine code cache. That's that thing I geeked out about before that gives you potentially 20 to 30% perf boost, or will. It gives you a little boost now, but it's going to give you a big boost later. So I do all of that stuff. Experimental support. I support top-level await. Right now, that's actually at stage 2 on the standards process. It looks like they're going to want to go with variant B without the C clause. I support variant B with the C clause. All that means is that it's still in flux, which is why it's experimental, which is why you have to opt into it. But it allows you to do top-level await, which is you can just say await this async thing, and it executes without having to be in a function. You can just write it straight out. It's almost like what you've been able to experiment with on like the Chrome console. You can do that now in Node. Let's see. I think. Oh, I added support for top-level await in Babel too, so you can lint. Great. So here's some resources. Here, there's my Twitter. The pinned tweet on my Twitter account takes you to the release blog post, which then takes you to videos and more information on this. There's a really good blog post about deep diving into ES modules and how browsers handle them too, and that's there. I will probably release my notes at some point, or in my slides, so just follow up and get them so then you can get these links. Cool. That's it. So now, with whatever time I have left, questions. 2 minutes? Sweet. Questions, yeah.
So you're doing transpilation on the fly.
Mm-hmm.
Can you incorporate more transforms than just the module transform on the fly?
I could. I don't want to, though, because I want it to be very fast. And so I've optimized heavily for the import, the export. I cover a val. I cover some live bindings. I cover console. But the whole point is that it's going to be really quick. And ESM works with Babel, too. So if you want to use Babel and add these experimental syntaxes and like JSX and all that stuff, this ESM doesn't obstruct that either. You can actually disable the module transforms from Babel and just let ESM handle it, and then let Babel handle all the other transform stuff. So that's what keeps this stuff microseconds instead of multiple seconds. So if you compare this to Babel, ESM is significantly faster, like 4 or 5 times faster. Yeah. Cool.
I'll take one offline.
Sure.
Well, okay. Thank you for doing JS, because a lot of people know, big companies, we don't want lots of testing frameworks. We want the same in the front end, the back end.
Yeah.
So we don't have to train anyone. So that's a good thing.
Yeah.
Okay. A lot of people, we just transpile. We put it in modules, say, okay, running using Node, whatever. We want to use the fancy features. A lot of developers only care about the fancy features. Tell me how to sell it to them.
For the fancy features?
No, all they care about is async await, maybe running Node 6, they want Node 8 features. But with ESM, they're already getting the imports and so forth.
Right.
Through
So they're getting import, export, and then if you use those Node versions, then all of that stuff still works. So you have top-level await, or sorry, you have await in Node 7, you have big int in Node 10.4, you have all of that stuff. So you get all of the existing cool language features and import-export with very low friction to adopt import-export. Oh, what's also cool is that this works with Webpack, too. So you can use ESM, set your module field in your package.json to the ESM entry point, and then let that index file just melt away, the one that you're using for your bridge. And then Webpack, Rollup, all of that stuff continues to work without any extra configuration. And if you use npm init ESM, it's already got the module field added in there for you, so you don't have to even configure that. Cool. Anything else? Great. Catch me in the hallway if you have other questions. Cool. Thank you.